So chapter 6 is something new that you haven't seen in grade 10 academic math at all. And we'll start with 6.1 periodic functions and their properties. So what does periodic mean? Something that's happening or appearing at regular intervals. So it has a repeated cycle, right? So for example, this graph that you see in front of you here, if we start at the origin, it's coming up, it has a peak, it's coming down, it's going back up, and then it's going to repeat itself and it's going to keep repeating and have like a wave basically look to it. So it has a repeated cycle. So that means that it is periodic. The peak is again the highest point on the graph, so it doesn't get any higher than this. And then conversely, the trough is the lowest point on the graph, right? A period is the time needed for the action to repeat itself. So it's basically one complete cycle. So if we look here, the period starts here at this red vertical line and ends here at this red dotted line. So from here, it peaks, it troughs, it comes back up here to the x-axis, let's say, and then it would repeat itself. So when the cycle starts and ends would be called the period. A cycle, a series of events that are regularly repeated, a complete set of changes starting from one point and returning to the same point in the same way. So basically a cycle just means that something is being regularly repeated, right? Over and over again. So now let's look at, so we've looked at everything in here. We've talked about the peak, we've talked about the trough, we've talked about that this would be cyclical, a cycle, so periodic, and then the actual period is where it starts and ends, and where the cycle would start over again, would be the end of one period. So what is the equation of the axis? So the equation of the horizontal line that's actually halfway between the maximum and minimum, okay? So if we look at, this is the maximum point, the peak point, and this is the minimum point, the trough value here. So halfway in between would be this black line that we've drawn. So that black line is called the equation of the axis, and it is the horizontal line. And it is also seen in this picture here. You can see I've got my peak, I have my trough, right? So that dotted horizontal line just means that that's the maximum value. The dotted horizontal line here at the bottom means that's the minimum value. And directly in between them is our equation of the axis, our solid horizontal line. So how, if we had a calculation, how would we figure out that horizontal line? So we would call that y, because again, a horizontal line crosses the y-axis and has the equation y equals. So y equals the max value. So maximum would be just the y value of the coordinate point, right? And then we're talking about plus, kind of an average, add the minimum value. So add the y value at the minimum point and then divide it by 2. That's not done very well, but a divided by line and then divide by 2, okay? So max value plus min value divided by 2. And I'm just going to clear that so we can move this up. So what is the amplitude? So if we're looking at the same type of picture as above, right? We still have our period here is the same. Our peak is there, our trough is there. This is our equation of the axis, of the horizontal axis. What is the amplitude? So that's a new word, maybe definitely that we didn't do in grade 10. I'm not sure if you've learned it in science. The distance from the function's equation of the axis to either the maximum or minimum, because it would be the same value, right? So from the middle point of the graph to the highest point, from the middle point of the graph to the lowest point will be the same value. So how do I figure out a formula for that? So for amplitude, we just call it AMP for short. AMP is equal to, same thing, it's the maximum value. So again, the y value at the peak, but now we're subtracting is the major difference. Subtracting the minimum values, the y value at the trough, and it's also the same thing of dividing, I did the same thing, of dividing by 2. So you just have to make sure you don't get those mixed up. If I want the equation of the horizontal line, I'm going to add max plus min divided by 2. And if I want the amplitude, it's maximum value minus minimum value divided by 2. Okay, so let's look at, I'll give you a second perfect timing to look at this example 1 and just give it a quick look over before we answer it together, because once again, my battery on my laptop is dying. So I'll plug it in while you have a look at that. Okay, so given the following graph that represents the motion of a chopping machine. So something that is chopping things up. So whether it's a chopping machine for vegetables, whether it's something for your yard, determine the period, determine the max and min height, and so on. So if we look at this here, what is the period? So again, if we look up above, the period is the cycle, right? So from the beginning to the end of one cycle. So here I have to take a look at the graph. So if I'm starting here, I have a horizontal line, it's going down, it's coming back up, horizontal line down, it's going back up. So basically from, let's say, this point here, close to 2 seconds, to this point here, close to 4 seconds, and then it's repeating itself, and then it's repeating itself, and then it's repeating itself. So then we're going to say that one of these cycles here would be the period, right? So we're going to say that that's a period of 2 seconds. Just to write that down. What is the maximum height? So the maximum height is the peak. The highest point on the graph is here at 2. So 2 centimeters it says here. So 2 centimeters. And just to go over, that would be the peak value. So Y value, right? What is the minimum height? The lowest point on the graph here is 0, which would be the trough. What is the equation of the axis? So remember, for the equation of the axis, what was it again? Was the first one the adding or the subtracting one? So the equation of the axis is adding the two together and dividing by 2. So I'm adding my maximum value together, 2, to 0, 2 plus 0, dividing by 2. So 2 plus 0, the numerator, would be 2, divided by 2 is equal to 1. And the equation of the axis is going to be y equals, right? So the equation is y equals 1 is the actual answer to that question. So I would have to put, I think I can do a line here if I take a look, a straight line. Yeah, let's see how this goes. Starting at 1, perfect. I do a straight line across. Okay, if you can see that there. And that is y equals 0. So that is my equation of the axis. So what is the amplitude? So again, the amplitude is taking the maximum value of 2 and subtracting it by the minimum value of 0 and then dividing by 2. Now, in this case, it might be the same answer, right? But it's not always going to be because of the 0. So 2 subtract nothing is 2, divided by 2 equals 1. But in this case, it's not an equation. The equation would be y equals 1. The amplitude is 1 centimeter. I would say it as a unit. So for example, remember, it's from the equation of the axis to the highest point. So from here to here is my amplitude. Or from the equation of the axis to the lowest point, from here to here is also an amplitude. So just, you can see it's a distance of 1 to 2. It's a distance of 1. Here it's a distance of 1 to 0. It's also a distance of 1. So they're both a distance of 1 away, right? 1 centimeter is the size of the amplitude. What is the meaning of the horizontal lines for example, number 2, this number 2 circle here, and the number 3 circle. What is the meaning of those horizontal lines, 2 and 3? Meaning, why is it horizontal? What's happening in terms of the chopping machine? So if here it's coming down, going back up, it's not coming down or up at this point. So if I had a chopping machine that's not moving up or down, it's not moving at this point, right? It's sitting still. Now it's coming down to cut, it's coming back up, it's resting. It's coming down to cut, it's coming back up, and it's resting. So that's basically, if you wanted to say, it's a resting point. So the blade, let's say the blade is up in the air. The blade is up and not moving. So it's not chopping anything at that point. It's just resting. Okay. What is the meaning of the V shapes on the graph? So like we just talked about this, where it's coming down and going back up, the V's coming down and going back up. That's when it's actually chopping, right? The blade is cutting, but because it's called a chopping machine, we'll just say the blade is chopping. The blade is actually cutting at those points where you see the V's, right? So let's look at, get that down if you need to pause it, and let's look at another example. Now this is, okay, so we've got part of the question there on the top, on the bottom of that first page, sorry. So while riding a Ferris wheel, Ryan's height above the ground in terms of time can be represented by the graph. So we can get everything from the graph, right? Basically, Ryan is on a Ferris wheel. Here's the height, here's the time on the Ferris wheel. So then let me see if I can zoom out a little bit. Usually, yeah, usually it doesn't work for me here. Okay, there we go. So we can answer some of the questions. What is the period of this function and what does it represent? So again, period is when does it start and stop one cycle. So if here I'm starting, and if we use some logic here, you're like, well, how is he starting on this Ferris wheel? That would be a 7, right? 7 meters in the air. So if you think about when you go to get on the Ferris wheel, it starts down at the bottom, and then as they load other riders, right, you could have ended up, let's say, halfway up in height on the Ferris wheel before the ride actually starts, because we're not setting the time to start until the ride is actually starting, right? We're not counting loading everybody on. So when the ride actually starts, Ryan, so he would be halfway up in the air, right? Then he goes up here to the very peak of the top of the wheel. He's the highest in the air. And then he's coming down. Now this would be the lowest point of the Ferris wheel. When you're coming down, now you might be saying, how come it's not hitting 0, right? Well, the bucket itself that he's sitting is not physically going to be laying on the ground, right? We need room in between for your legs to hang, and even below that, right, we would have some extra space. So if you can see here, that makes sense. That's about 1 meter in the air. The lowest point of the Ferris wheel itself would be 1 meter in the air. And then we come back up. And then when we hit 7 here, that would be our 1 cycle, right? So if I can go over this here, let me change my thickness here. 1 second. Oh, there it is, line width. So if I make a thick line here, starting at 7, I'm going to try to reaching the peak, down to the trough, and back up to 7, making sure I'm stopping at 7. That would be a period there, correct? Okay. So what is the period of this function and what does it represent? So how long does it take? So it takes, you can see there, 40 seconds. So 40 seconds is the period. And what does it represent? So that means it takes 40 seconds to complete 1 full rotation of the Ferris wheel. So it takes 40 seconds to go, say, one complete rotation. One time all the way around in the Ferris wheel. Okay. What is the equation of the axis? So the equation of the axis is, again, maximum plus minimum divided by 2, and it's a horizontal line, right? So basically, where is the exact middle value? And you could probably see that already since we started at 7 and the period starts and ends at 7, that would be the middle of this graph, right? But as an equation, I would have to write out y equals, let's move this out of the way here. I would have to write out y equals max plus min, and then divide by 2. So the maximum value is the peak value is actually 13 if you see there, plus the minimum value here for the y value is 1, and then divide by 2. So 14 divided by 2 equals 7. And again, that's an equation, so it's y equals 7. So y equals 7 is the equation of the axis. And if we want to draw that in, here, change my color. I've got my equation of the axis right there. Okay, so there is my y equals 7. Okay, next question, what is the amplitude? So I'm just going to do that answer over here so I don't have to clear the screen. So the amplitude this time is the maximum minus the minimum divided by 2. So the maximum value is 13, the minimum value is 1, divide by 2. 12 divided by 2 is equal to 6. So the amplitude is 6, right? What does that represent? So if we look here, if I change the color, right, the amplitude is from the equation of the axis to the peak. So even if I was to count it from 7 to 13, right, 1, 2, 3, 4, 5, 6. From the equation of the axis to the trough, this distance here, 1, 2, 3, 4, 5, 6. So even if I was to count it, I would see that the amplitude is 6. So if we think of it from a Ferris wheel perspective, what would that mean? So I'm still on C here. If this is my Ferris wheel, right, just pretend, my amplitude here is equal to 6. That would be the radius of the circle, or the radius of the Ferris wheel in this case. Okay. Okay, now I have to clear it just to answer the last few questions. D, E, F, and G. So what is the range of the function? So the range of the function, right, is the y value. It's going as high as 13 and as low as 1. So to write that out, range is R, right, is equal to y belongs to the set of real numbers. It's a solid line, but such that y is greater than or equal to 1 and less than or equal to 13. Okay? After 70 seconds, when will Ryan be at the lowest height again? At the lowest height. So let's go up and look at 70 seconds. So here's 70 seconds. So he's now at the lowest height. So when will he be at the lowest height again, right? So if we were to imagine he's going to be going back up and then coming back down and getting the lowest height again. So if we could look here, the lowest height was at 30. By the time I come back up, reach the peak and come back down, I'm at 70. So what's the difference between 30 and 70 seconds? 40 seconds, right? So it takes 40 seconds to complete a cycle from the bottom, to go one time around in the Ferris wheel. So I could also just take 70 and then add 40 seconds to it, right? So for this answer here, we can just say, take the 70 seconds and add 40 seconds, which is 1 period. And I'm going to be at the lowest point again after 110 seconds from the beginning of the ride. Okay, at 110 seconds, he will be at the lowest point again. At what times is Ryan at the top of the wheel? When is Ryan at the top of the wheel? So let's go up and look. At what time? So the peak here is at 10 seconds and the peak here is at 50 seconds. So we just simply write that in. At 10 seconds and at 50 seconds. When will his height be 7 meters between 700 and, oh, that's just 70, sorry. That's a typo. Just, when will the height be 7 meters between 70 and 110 seconds? Because if I go up here and look, between 70, the end of, so between 70 here is starting another period, another cycle. So between 70 and 110, right? If I take 70 plus 40, I'd get to 110. So for another whole entire cycle, the question is, when will the height be 7 meters? When will the height be at 7 meters here? So I can already have, one of the answers is right in there, right? So there's a height of 7. So what would my number be down here? So every 3 is 10. So 1, 2, 3. So that would mean this is at 80 seconds. And what I can also do is say, okay, if, let's draw it back in here. If this is my equation of the axis here, which is my 7 meters, and I'm at the lowest point because 70 is at the lowest point, right? How long does it take me to get back up and touch that line? From 30 to 40 seconds, so 10 seconds. So it also makes sense to just add 10 seconds to this answer. And then once I'm at 40 seconds, so for while it's reaching the peak and coming back down and approaching the equation of the axis again, that's taking from 40 to 60 seconds. So that's taking an additional 20 seconds, right? Or it's taking, from the lowest point, it's taking 30 seconds. So let's see how I want to write that down. So unfortunately, I have to clear this. So at what, when will his height be? 7 meters between 70 seconds and 110 seconds. So at 70 seconds, remember we said we would add 10 seconds to that, and it would be at 80 seconds. And then from the 80-second mark, remember it was 20 seconds away on the previous period we looked. So then that would also be at 100 seconds. Or you could have written down 70 seconds plus 30 seconds and still had your answer of 100 seconds there. Okay, so in summary, a periodic function is a function whose values are repeated at equal intervals. So it's always happening in this example every 40 seconds, right? A period happens in the independent variable x along the independent variable. So if you want to read more about this, if you feel like you don't quite grasp it, go in your textbook, page 346 to 351 to see more examples. And then when you're ready, try page 352, 2, 3, 4, and 5, 7, 8, and 10. Because again, one question from 6.1, right, would be on your a quiz or a test.